Hello, Mr. Luong. This is my FRQ number 7. So for part A, the free body diagram is going to look like this. So that is the mass of the car, and then there's force of gravity acting on it. And there's also Fn. And the acceleration is going to be pointing toward the center. So it is going to be look like this. So for part B, I'm going to write the Fnx and Fny because I want to find Fn, which equals to Fnx squared plus Fny squared. So then Fnx is going to be the force of, which Fnx is the centripetal force acting toward the center, which is going to be mv squared over r. And the Fny is going to be mg. And I know that tan of theta is going to equal to r over h. So then the radius is going to be h tan of theta. Now to find Fn, I just need to plug all that in. So mv squared, r is going to be h tan of theta square plus mg square. So all that under the radical, and that is how I derive the equation for Fn. And then for C is just like I said before. To find the centripetal force, you just need to know the Fnx. So centripetal is going to be Fc equals Fnx. Fc is going to equals to mv squared over r, which equals to mv squared over h tan of theta. And that is how you do find the Fc for part C. And then for part D, I know that the Fnx is the centripetal force, so I can set it equal to mv squared over r. And then Fn sine of theta is going to equal, which is Fny, is going to equal to mg. So then since they both have an Fn, I'm going to isolate both sides for Fn. And I know r is h tan of theta, so I can put that in. And tan of theta is sine over cosine. So tan times cosine, the cosines will cancel, so you're just left with sine of theta, which is going to be mv squared over h sine of theta. And now I'm going to set this equals to mg over sine of theta because they're both equal to Fn. So then the m cancel out, the sine of theta cancel out. So you're just left with v squared equals to hg. So then v is just going to be rad hg. Okay, so for part E, I'm going to make the x and y chart. And the forces acting when the car is, when the car is going at maximum speed, you want the Fs to point downward because you want to keep the car from slipping out, right? So you need the FS to hold the car to like point. You need the FS to you need both FS and FNX to you need both the FSX and FNX to point toward the center for the car to not slip. Yeah, so that's why for Vmax, FS is going to point down, which is going to affect the signs. So for X, the forces acting toward the center are FNX and FSX. So that's why they're the centripetal forces. So the total centripetal forces are FNX plus FSX. And then in the y direction, the forces that are okay, so there's going to be FNY, which is going up, and then there's subtract FG, subtract FSY equals to 0 because the car is not accelerating upward. And then I'm going to expand everything out. Actually, I'm going to move the MG to the other side so it's easier to do everything later. Okay. Oh, there's the MG. And now I'm going to isolate both sides for M so I can set them equal to each other. And also, I know that Fs is going to... Here, let me write that somewhere else. I know Fs is equal to mu S times Fn. So, I know that since both of these have Fn, I can take them out. And I'm also gonna do that at the same time to save time. So M is going to be, like I said before, I'm going to take the Fn out. And there's Fn in here, so which is going to leave Fs with just mu s. So Fn cosine of theta plus, oh wait, there's also R. Yeah, so R there, Fn there, and take Fn there, Fn out, so it's going to be left with cosine of theta. And since Fs is equal to mu s times Fn, if I take the Fn out, there's going to be mu s and sine of theta. All of that over v squared. And same with this side, I know Fs has Fn in it, so I can just take it out. So then sine of theta minus mu s cosine of theta equals over g equals to m. And now I just set both sides equals to each other. And then the Fn cancels. So to get Vmax, oh yes, this is Vmax. To get Vmax, I'm going to divide this cosine of theta plus mu s sine of theta to the other side. So R V max squared equals to sine of theta. Oh, I'm also going to move the Vmax to the numerator of the other side. How about I just do that all in one? Okay. So RG is because you move G to the other side. And then cosine of theta plus mu s sine of theta. And then there's b squared max moved to the sine of theta. But then, okay, should I write that? Okay, so then you just divide both sides with sine of theta minus mu s cosine of theta. and then you square root that to get V max is going to be RG cosine of theta plus mu s sine of theta all over sine of theta minus mu s cosine of theta. That is how you derive the expression for V max. And then for part F, it's going to look very similar to part E, but the only difference is that the signs change, because this time instead of FS pointing down, you're going to have FS pointing up, because you want FS to point up to prevent the car from slipping. And this is going to change the signs, because instead of FSX pointing this way toward the center, FSX is going to point outward. So the FC is going to be FNX minus FSX. And the FNY is going to be pointing upwards, which is also going to change. Oh, not the FNY. The FSY is going to be pointing upward, which is also going to change the forces acting in the Y. So then for part F, I'm also going to draw another X and Y chart. Or can I just copy and paste? I think copy and paste will be the smart idea, because saving time and work smarter, not harder. Okay, yes, okay, oh wait, why am I going? Oh yes, okay, sorry. Let's copy and paste this right there. And now paste this right here. Uh-oh, okay. Oh, I do not want E, that is F now. Yes, okay. And so everything, like I said before, is going to look the same except the signs change because of the change. FS is going to point upward instead of downward now. So since FS is pointing upward, the FSX is going to act against the FNX, which is going to cause the FNX, the total centripetal force, is going to be FNX minus FSX. So then the signs change to minus. And then instead of V max, this is going to be V min. And then since the forces acting in the upward are FNY and FSY, I'm going to move FG to their side here, FG. So this is going to be plus FSY equals to MG, because like I said before, this is going to be here. I will make a drawing later to show you what I mean, but for now, so I know that FNY plus FSY is going to equal to MG, because they both equal to each other, because there's no acceleration in this Y direction. So then this is going to be plus. And like as before, to find V, I can just isolate both sides for M, set them equal to each other, take out the Fn from both sides, and then cancel out the Fn. So then V min should be, so it's going to be Rg cosine of theta minus mu s sine of theta equals to V min square sine of theta plus mu s cosine of theta. So then you divide both sides with mu sine of theta plus mu s cosine of theta. Square root that. Then V min is going to be rad Rg cosine of theta minus mu s sine of theta over sine of theta plus mu s cosine of theta. Okay, so that is for how you derive the equation for V min, which is going to be equals to rad Rg cosine of theta minus mu s sine of theta over sine of theta plus mu s cosine of theta. Now for part G, it asks to find the net force given by the function, and I know part G, net force, I should rewrite that so it's easier to see. So net force, can I copy and paste this? Well, it's probably gonna copy and paste the whole image, would it? I'm not sure. Let's try. Oh wow, that is so cool. Oh my gosh, that is very cool. Okay. So the F net is going to equal to this, and I know the net force acting on, what is it, the car again? Is it the car or the block? Okay, it's whatever. It's the mass. Yes, it's the car. So the net force acting on the car is the centripetal force, and the centripetal force, the total and other centripetal forces acting on the car is going to be F. So net force equals to FC, and FC equals to Fnx plus Fsx. This is assuming that you want us to derive the equation for net force when the car is going at a maximum speed, okay? And then I also know Fc equals to MAC. And then I would like to solve for AC because it's going to be most simplest, because from before I found that I am going to reuse this part right here. So before, when I did set both of when I solved for Vmax before, I found that there's R over Vmax square, and that is looking very similar to V square over R, which equals to AC. So I'm going to manipulate it so that I can make it look like V square over R, so I can plug that back into this right here to get the net force. So then I'm going to divide both sides by cosine of theta plus mu s sine of theta. I'm just going to remove the max so it looks cuter, I guess. I don't know. Sine of theta minus mu s cosine of theta, and then G times cosine of theta plus mu s sine of theta. And then to get V squared over R, I just flip both sides. So you get V squared over R equals to G cosine of theta plus mu s sine of theta over sine of theta minus mu s cosine of theta. And then to get this to look like cotan, I just divide everything over sine of theta. So then V squared over R is going to be G cosine of theta over sine of theta is cotan of theta. Oh no, what just happened? Okay. Oh no, okay. Oh no, what just, okay. So cosine of theta over sine of theta is cotan of theta plus mu s. Sine of theta over sine of theta is just 1, so it's just mu s. And then sine of theta over sine of theta is 1 minus mu s. Cosine of theta over sine of theta is cotan of theta. Does that look like cotan? Sorry, my handwriting is so bad. So then it looks, so I just got V squared over R equals to G times cotan of theta plus mu s over 1 minus mu s cotan of theta. So now that I got this equals to AC, I can plug it back into FC equals to MAC. Then, so FC, which equals to the net force, which equals to M, AC is G cotan of theta plus mu s over 1 minus mu s cotan of theta. And that is how you prove that the net force is going to equal to mg times cotangent of theta plus mu s over 1 minus mu s cotangent of theta. So, oh wait, oh, the m is supposed to be capitalized. Yes, that is it for G. And now this is the supplemental part. You can keep watching if you want, but this is how I'm going to prove that I found my angle to use for this problem. So let me draw the plane right here. Or let's just do another page. So I'm gonna make it very big so it's easier to see. The plane right there. This is the block. This is the block. Okay, and this is the center of the cone. And there's FG. And this is going to be FGY, FGX. And now let's call this theta with the center of the cone theta 1. And this angle theta 2. And then there's a 90-degree here. Oh, that's a 2. There's a 90-degree here. So this means that this theta 2 is good. This means that this other angle is going to be theta 1. Because theta 2 is right here, that means theta 1 is right there. And also because there's theta 1 here, which means according to alternate interior angle theorem thing, whatever it's called, these chord angles are equivalent. So then, yes, that's how you get theta 1 here. And then there's also Fn. I'm going to make Fn touch this so it's easier to see. But realistically, Fn is not going to look that much greater than Fg. So that's Fn. And then there's also Fny. Here, this is going to be Fny. Going to be Fnx. Okay. And now, since this angle theta 1 is here, the angle opposite to it is going to be theta 1 as well because of another theorem. So I forgot what the name is, but it's called, is it corresponding angles? Yes, corresponding angles. So these are the same. And then since there's two angles to make a 90-degree, and that's same with here, then this angle has to be theta 2. And same here, since that's theta 2, this has to be theta 1. So that's how I got the angles to find for the Fnx and Fy, the Fnx and Fny, and that's also how I was able to find the Fs and Fs when it's pointing up, when it's pointing up and down, because I can use this angle to find Fsx and Fsy, and I can also use this angle to find Fsy and Fsx. And yeah, I think that's how you prove. That's how I found what angle to use for, and what kind of, like, which sine and cosine to use. And I